Right, welcome back to part 2, I think it is, for the tutorial. And we're looking at the simplifications. So for this particular one, just to point out there's a couple of different ways to do it before we get to the integration. So the first thing to notice is on the numerator. What's your instinct telling you about the numerator? What's going on with the numerator? Anything in particular? Well, it turns out that if you look at the numerator, there are no loose numbers. Okay? So that means that there is a couple of different options for us. Because there's no loose numbers, the rules of algebra tell us that we can take what's common. So what we can do is take a common factor out. And in a sense, what that does is allow us to eliminate those. The other thing that we can do, instead of doing the common factor idea, is simply to split fractions and treat them like individual terms. Now these will cancel, these denominators will all cancel. They're all equivalent. This is the previous step. Okay, so you can cancel them and rewrite that as 3. Cancel them, rewrite that as 2. Cancel them, rewrite that as 1. So this becomes the integral of x cubed plus 3x squared. Now it appears, it occurs, that you can just go along turn by turn. How do we go over here? This needed to be x3. x3 times x is x4, tick. This needed to be 3x squared. 3x squared times x is 3x cubed, tick. And this one needed to be x times x is x squared. So they can now cancel, and you're left with just what's in the brackets. We'll remove the brackets. And so we have exactly the same thing. Okay, now we're ready to do our integration. So up and under, I'll just get rid of that and put it just from there up. So up and under 3x4 divided by 4 plus 3x3 divided by 3, so that's going to cancel. Minus x up and under is going to be x squared plus c. So the only thing that made a difference there was that one. And that's your final. Okay, how you put them together is a little bit dependent on what Pearson wants. Okay, 2 different ways to manage your factorising. Alright, the next one we want to consider is g. And so for g, it's an integral of a 2-term product or a binomial product. There's no particular patterns to these. It's just a quadratic. It'll be a non-monic. And so the only thing that's left to do is a FOIL. FOIL first, outside, inside, last. Okay, so there it is. Alright, so let's do that. Not ready to integrate yet, so 2p times p is 2p squared plus 2p minus p minus 1. Change your pronumeral. This is the sum term. 2 apples minus an apple. 2p squared. 2 apples minus an apple is an apple. So we're just left with p minus 1p. So all we can do now is go ahead and do the actual integration. So we'll end up with up and under. Up and under. and this one, it's x to the 0, so it'll be minus x plus c. That's your final result. Alright, so fairly good in that way. Just what we needed, really. Alright, let's have a look at h. For h, we've got integrate s minus 2. Yes, now there's two ways for you to do your pre-work. It's entirely up to you how you do your pre-work. Okay, but essentially what we can do here is we can recognise that this is s to the half on the bottom, and we can go s minus 2 into a bracket, do s to the minus a half, so that's pulling it up. Okay, the alternative thing we can do is we can split the fractions. Either way is okay, it's your preference entirely, but we have to do an expansion here. So we're going to end up with s1 s to the minus a half minus 2s to the minus a half. Yes, this is this adding fractions again, or adding indices. So we'll end up with a half, 1 minus a half is just a half, and 2s to the minus a half. So that's ready to be integrated. Okay, here we've got this one going up, so it's s to the half, so that's exactly the same thing. Again, minus a half and minus 2s to the minus a half. So that's the same thing. So that'll get you into this space here. So we can go ahead and do the integration. So it'll be s to the half plus 1 minus 2s to the minus a half plus 1 plus c. So a half plus 1 and a half minus 1. So we're going to end up with s divided by half plus 1 divided by minus a half plus 1. So that's 3 on 2 divided by 3 on 2, which is 2 on 3. Minus a half plus 1 is just a half. So we'll have minus 2s to the half divided by a half minus a half. We'll just put that out. Plus c. So we can see that this is going to change that. So it'll be 2 on 3, the square root of s cubed, minus and a minus will make a plus, times by 2 will give you 4s square root of s plus c. Okay, so I'm happy to check that against technology actually. So there's quite a bit there, so I'd like to do that. Just get it to let me know if my computations are sound or in need. So we'll just put this over here. And we're integrating the quotient s minus 2, close the quotient, and divide by the square root of s. Yes, so Wolfram knows what you're talking about when you're talking about a change of cranial. So let's just see if that's the correct form. It is. Okay, so in its wisdom, it's put together an answer that's very similar. So let's just check that. Okay. It looks nothing like it, does it? So let's just put this together 2/3 the square root of S3. I could do it the long way, but I don't want to do that. 2/3 the square root of S3. I'm just going to have a bit of fun here, alright? 2/3 the square root of S cubed. S to the power 2. And what else have we got? Plus 4 root S. Not doing anything there, just having a bit of a play with our algebra. Mix match, what have I done there? Don't need that one. Let's have a look. So that's how I've put it. 2/3 square root of S cubed plus 4 square root of S. So that's alright, 2/3 of, and that's a cube. Cube. And I think we can tell it's a simplify. Sorry, I'm just having a play around with it because we checked it. And there you go. That's the same as the previous answer. So 2/3. Now what's happened here is it's been a bit tricky. There's some tricky algebra that's gone on there to have a common factor of 2/3. In order to have a common factor, that's a very complicated thing, so I'm going to do it. Okay. Better explain this. Because it comes up in the future anyway, so we might as well do it properly. Actually, I just want to minimize this a little bit. Let's push this over. Push him out of the way a little bit. Let's just see if we can do this. Okay, so in order for us to take 2/3 as the common factor out of this bit, we would need to cancel a 4. So that means we need to be a little bit careful about that. So 6 on 3 would be 2, wouldn't it? So if we replace that with 6 on 3, if we think about this way, 2/3 S cubed. Now, if we replace that with 6 on 3, that's 3 2/3 times 3. So what you can see there is that times 2 so that would need to be 6, so let me work it that way. So 2/3 S cubed plus, now the factors of 6 are 3 and 2. 3 and 2. Okay, so those two there represent 4. That's that number. And 3 over 3 represent 1. So by taking this and multiplying it by splitting the 4, and that's the tricky bit. Okay, so let's just take that up, do the operation just as the way we saw it. So we've got 2, 3, S cubed plus 4 with S. I'll just leave the C out of it for the moment. Now, this 4 is going to be split into 2 2's. Nothing wrong with that. Now, in order not to change this expression, we can multiply it by 1. The form of 1 that we're interested in is 3 on 3. So at the moment, they're the same. Okay, what you can see is that we've got one of the 2's and the 3's represents, so let me just do that as a rearrangement. So if I make that a deliberate 2/3 times 3 times 2. So what we've got there is a root 6. Okay, 3 2's are 6. So we get 2/3 is an equivalent. I know, right? 2/3, 6 root 3. So if we take the 2/3 out as a common factor, we can have the square root of 3 cubed plus 6 the root of 3. Okay, so essentially that's just some algebraic manipulation. Look, it's a good exercise to recognise that that is the same. One more as that. Okay, because now what you're able to do is see that you can now manipulate that. Okay, so if we take out root 3, this here can be manipulated, and so we're able to go one more step. Okay, but I'm going to leave that there because we can play all day with algebraic gymnastics. That's hilarious. All right, so that was a bit of fun. For the next ones, I think I might pause there and come back because we'll finish off these together in one video. All right, well done. See you soon.